to everybody. I think you saw already a lot of presentations. You asked a lot of questions about digital substations. A lot were well answered, and I think this presentation honestly will bring a lot of complementary answer to everything you asked about digital substations. So today is a bit special because there is no who I am, there is a who we are. So I'm with two people with me to present the project. So Anthony Bury hosting the presentation from Straton Automation. We have also Michael Dananché from RTE, which is the French TSO, the biggest TSO in Europe. And Erwan Roussi from Savoir-Faire Linux, which is a company specialized in open source software. So I wish to present everything we do in the companies, how many we are, since when we exist, but we chose to go directly to the technical point, so you are here to see technical things, so you will not be disappointed, I think. So we talk about digital substation. First, a really quick introduction about what was before and how it evolved in few decades, because the world is running really quickly. So how did it evolve in few decades? So we went from this, I said a few decades ago, to this, and this generated by AI, by the way, so it's even more the future. From old PCs to really powerful stuff, from old thermic cars, which is from Holland, by the way, but it is a French car, to new electric vehicles. And if we want to power all of it, of course, there are substations somewhere in the middle. So if an old substation looks like that, what does it look like today, or what will it look like in the future? So what are the main challenges today about substations? Mainly building and retrofitting substations. So for both, it's almost the same challenges. At the time, you need to do some design, even if it's retrofitting a substation, you need to draw some stuff. You need to choose some communication protocols. We hear a lot here that there can only be one, which is 850. But we saw yesterday that there was not only one, there are many others to cope with. So 101, 104, Modbus, I don't know, MQTT, communicate the outside, also cyber protocols. You need to do some tests internally, validate the solution that it works in simulation, and then commission it. Once it's commissioned, you need to think about the maintenance, and you need to think about cyber security, about firmware update, about compatibility, about adding new IDs, about a lot of stuff. So of course, these challenges, it's really not easy. So the question is there an easier way? By the way, I think the parentheses are not at the same right place, because easy, we know that there is nothing easy. So is there an easier way? So we are at the 21st century today, the world of digital, virtualized world. We hear it a lot since many years. So, okay, a digital substation, what could it look like? So, first, virtualization. Again, a quick introduction. I think you already saw that a lot, so I will be quick there. What have been virtualized already? Yes. You know the ABB protection, it has been virtualized, there is the reference, but we heard about that already a few slides, few presentations before. IDs have been virtualized, the CPAF project, we saw it also, virtual IDs running in CPAF. We at Straton Automation developed virtual stuff, so we developed a virtual PLC initially since 2002. With this PLC, you can develop functional working, so you can develop a virtual IED with Straton. If you go on our website, there are virtual IED, virtual server running on Windows, or virtual client. PLCs are virtualized also. It's recent but old. Siemens announced their virtual PLC a few years ago. I think it was 2023. Codesys announced it in 2000 something, but they do it also since before. Straton Automation, we do it since 2002, virtualizing PLCs. And last thing I wish to present is data transfer. So, we went from many cables to less cables, thanks to IEC 850. So, a digital substation. Question is why? We will not do it for fun, because we saw there are a lot of challenges, so why did we choose to go in this way? Mainly about the design. We spoke about the design. What if there could be a design made by one file, so the system configuration description, only one entry point, you configure everything, the logic, the 850, the logical nodes, the communication, everything configured in one file, you deploy it and then it works. Magic. Then deployment and maintenance, because if it's digitalized, theoretically you can deploy it easily. You don't have to go on site. You just have to have a distant platform, and then you can deploy your images, your virtual IEDs, your protection, stuff like that. Also software flexibility, because if one logical node is missing, one IED is missing, you just have to replace an image. Finally, you just recreate the logic, add what's missing, and then you deploy the new image, validate it, test it, and then that's it. If it's digital, you can simulate it in a smaller cabinet, because you don't need to have a lot of devices, real devices that will send sample values, that will send some good messages. You just create virtual IEDs, and then you can validate theoretically that the control center is doing the right stuff. Cybersecurity. So also cybersecurity can be virtualized. You can create a virtual firewall, for example. Real-time could be virtual machines, real-time operating system. You have the technology's ownership also, if it's virtualized. Why? Because if it's based on open source, if it's based on source code, if you buy really this development kit to build your automation, to build your 850 communication, you have all this as source code. If in 5 years, 10 years, 20 years, there is a problem, you reopen what was delivered in the substation, and then you see, okay, this line of code was wrong, recompile something, create the image, deploy the image, okay, done. So easy. No, nothing like, but this provider does not exist anymore, they don't have a company, so how to change it because I don't find the documentation. Could be complicated. What about the life cycle then? Because if we change it also, this is because we need a long life cycle. So you all have a smartphone, we all have a Windows PC. We know that software-based stuff, it's always about, you have a new update, you need to install this update, okay. So finally, life cycle could be short if we see a PC, because okay, if I don't install the update, it's not running anymore, so what do I do? Okay, but long. Why long? Because as long as you install the updates, in fact, you can keep a PC for 10 years if nothing is breaking or the hardware is not breaking. Finally, it's only updating. There is a security breach, okay, you patch the code, you deploy a new image, and then that's it. So finally, a digital substation could, we will see in the future, but could have a longer life cycle, theoretically. At least this is what is expected. As said, theoretically, in years. So return of investment today, honestly, will not lie, we don't know. It should be cheaper, it should be better for TSOs, for DSOs, for people building substations, but it's too soon to say there is a good return of investment. About the timeline, about the delays, we'll see in a few slides. So roughly, to make a scheme about this, because it's a lot of text, we have one SCD file. You know what's in SCD file, I guess, here in the room. Configuration file for the substation. You configure the services, you configure the communication, all the 850, your IEDs, logical nodes, data objects, all the communication. You can configure in this SCD file the 1131-3 functional description. So all the conditions, like if this and this condition is reached, then I must apply this command. For example, if there is a too high voltage and this, then I can open the circuit breaker. So all of this, 850 communication, functional description in one file. you put it in a deployment script. So you build your automation, you build your communication, and then you can deploy it. You can deploy it as said as it's virtual and digitalized on Windows PC, for example, for the simulation. So of course it will have few other devices to test, but you can deploy it on a simple platform to do some tests already in-house. And then you can deploy it once it's validated in simulation on the real machine, and then communicating with real physical devices. And above that, you have a control center, you have your SCADA to control everything. So quick question to the audience then. We said it's digital, the future of substations. Who thinks that we are really far away, and who thinks that we are really close to do it? So first, who thinks that, okay, it's maybe you are dreaming, maybe it's we still have work to do, it will not happen today. Yeah. Okay. Oh, sorry. And well, we don't have that much time, so we'll not go through all questions. Who thinks that such a solution is already implemented and running somewhere in the world? Good. So I know a company who did it, and I let the stage to Michael Demancher from RTE.
Yeah, thank you, Anthony. I will present you today the R-Space project. So we are RTE, French TSO. We have more than 2,800 substations, and R-Space is our new generation of packs. It's a multi-vendor system. We equipped our first substation with it in 2023. And we use extensively the virtualization based on CPaaS. I will say a few words about it later, and we will have a detailed presentation of CPaaS with our colleague Erwan next. So what we are doing with CPaaS, for instance, is virtualizing some station level functions. So you have here an example of a station. We still have physical devices for the bay functions, for instance. So we are still using vendors providing physical devices, physical IDs, but for our station level functions, we are virtualizing it. For instance, the local SCADA, we have it there. So station operator functions. The gateway also is virtualized, so it's a gateway to send the information toward the global SCADA or global SCADA for dispatchers. And finally, I will focus today on the substation level automations, for which one we are using straton automation. So more precisely, what is virtualized for these particular automations? We have different types of automation needs. So for instance, automation for operators, so alarming automations, basically doing some grouping of informations. But we also have automations for operations, for instance, the switch breaker failure automation or the overload management. They are all done in virtual IDs. To do so, we use Straton software to develop internally the algorithms. That is to say, the engineers by RTE are using Straton software to write the code, in fact. And then we are deploying it in the CPaaS infrastructure. You can see here, we have three hypervisors, three CPaaS hypervisors, which allows us to have redundancy. Meaning, if one of the hypervisor fails, we still have two other ones that takes the load, I would say. So in these hypervisors, we have some virtual machine. And for instance, we have one Windows virtual machine hosting the local SCADA. We have one Linux virtual machine hosting the gateway, and we have one special, I would say, virtual machine hosting some Dockers for our automations. That means we have one Linux VM, but we have then several Dockers, and we are grouping the functions. For instance, if we have functions that have strong links between them, we are grouping them in one particular Docker. And if we want to isolate some functions, for instance, the switch breaker failure automation, which is the most critical, I would say, for us, then we can isolate the function in one particular Docker. And this is real. We already have 2 sites in production. You have an example here. On the right, you can see the hardware because we virtualize things, but of course, there is still some hardware. The hypervisor are hardware. And you have some images there of our local SCADA we have on site. So two sites are now fully in operations. The feedback we have from the maintenance, for instance, are pretty good, in fact. And we are now towards the industrialization of our process. So we are now, I think, a third site is currently under commissioning or a site acceptance test. And we are still starting in a few weeks the factory acceptance test of the first site. So the speed is increasing, I would say, for this site. I just give the word to Erwan for a quick introduction of CPaaS, and then I come back.
Thanks. Yes, just a few words about CPaaS. I will talk a bit more about it later. So CPaaS is an open source hypervisor, so virtualization platform, open source. We are under the governance of the Linux Foundation Energy, which provides all the rules and the support to have a neutral environment to build such a project. We bring many people around the table, manufacturers, vendors, utilities, IT people, OT people. The goal is to make everyone discuss around the project and to build a better project. The 2 main philosophy points of CPaaS, I would say, are first to not reinvent the wheel. So we do not want to rebuild everything that other projects really do very well. So we are built on top of many open source projects, well-established and well-maintained open source projects. I will present them a bit later. And also test-driven developments and DevOps approach since day one. So we have, of course, a CI running with intensive unit testing and integration testing. We have also static code analysis on the entire code base of CPaaS. And we have the silver badge of OpenSSF best practice for the CPaaS project.
Thank you. So just a few more words about our space project. First, some words about our development and test process. We have quite a long development and test process on your virtual IEDs. You can see here an example of the whole process. So we have development first, and then a certain number of qualification tests. For all of this, for development and unit tests, we are using Straton development environment. So we use it to write the code, of course, and we use it then to perform our unit tests. We automate it, but we use still the Straton development environment. And then in the second phase, we perform qualification tests. And in this qualification test, we use the Dockerized Straton runtime, which will be also then in production on our sites. And we use, of course, the full CPaaS infrastructure, which means when we are doing, for instance, system qualification tests, then we have the same whole infrastructure, the same whole CPaaS infrastructure as we have on site. So first, unit tests, easy. We check just if the logic is okay. So we check our algorithm, basically. If I have some breaker failing, I am sure that my breaker failure algorithm is functioning well. In a second step, we perform virtual IAD qualification, which is to say we add the 61850 stack and we check if it performs well. So we simulate the inputs and we check if the outputs are okay. Again, this step is fully automated. We have automated test tools we developed internally by RTE. Then we have a partial system qualification step. In this qualification step, we deploy all the virtual IADs, the HMI, so the local SCADA we have, and the gateway, and we check if all these virtualized parts works well together. So if it communicates well and if it works well. And finally, system qualification, then we add the physical IADs from our different vendors. All of these steps, this qualification, partial system qualification and system qualification is performed using a generic SCD site. The idea is we want to put in production many sites each year, and we don't want to qualify each time with the SCD. So we have a generic SCD site with all the functions we want to have in the virtualization, and we use this generic SCD site to perform our qualification tests. But of course, in the second step, then on-site, we have the factory acceptance test, and then the commissioning and the site acceptance test. For those one, FAT, SAT, and commissioning, we are using, of course, the specific SCD of the site. One thing more, at each step, except for the development and unit testing. So development and unit testing are performed on a specific infrastructure, I would say. So it's basically just one VM with a Straton. But then for partial system qualification, for system qualification, and so on, we are using the same infrastructure as we have then on site. So exactly the same CPaaS infrastructure. And then once our virtual IEDs are all qualified, what do? We put it in production. Again, quite everything is automated. So for each site, we have a specific site SCD, I said. I heard this morning, treat the SCD as the best friend. It's totally true for us. Everything is highly depending on the quality of the SCD we have. So this SCD is produced on RTE, is produced by a tool we developed in-house. So some colleagues have developed the software to generate our SCDs. And once we have these SCDs, we take it in our configuration tool. This configuration tool has also been developed internally by RTE. And this configurator basically reads the SCD, and it will see if there are virtual IDs, if there is a gateway, if there is the SCADA, and it will configure all of them automatically. Basically, for the virtual IDs, it will check the different virtual IDs in the SCD, and it will take the specific Straton algorithm. For instance, for the circuit breaker failure algorithm, it will take the specific Straton algorithm for this particular function. It will take also the generic Straton algorithm, meaning, for instance, how we deal with operates, GUSI, setting groups, and so on. And it will combine all of this to create the configuration file of the virtual ID. It will store it on a secured FTP, and then we can deploy it on site. So this configuration tool is performed on a centralized tools, and then we have a deployment tool on each site, allowing us to deploy the configuration, so the first one, or if there is an updated configuration because it evolves, we can of course use this deployment tool to deploy the new version of the configuration of a virtual IAD. And this particular task, this deployment task, can be performed easily by a maintainer. So it's not a hard task to perform, just almost clicking a button in the local HMI. One important note, this putting the virtual IADs in production is also used for the qualification steps, meaning, as I said before, we have the same CPaaS infrastructure for qualification, so we perform exactly the same procedure for qualification, meaning we take the generic site SCD, we configure the automation, and then we deploy this on the qualification infrastructure. Finally, to conclude my part, I will give you some figures on the virtual IADs. For now, we have 6 different IADs deployed on site, but we expect to have 40 of them in the near future. We are now dealing with more complex substations, bigger substation, I would say. So different new functions we want to have, for instance, for transformers or such things. We have up to 12 logical devices in each virtual IAD and up to 80 logical nodes in each logical device. And we are dealing with, as of for now, up to 40,000 inputs in each virtual IAD. Our cycle time is from 10 milliseconds to 100 milliseconds for now. And we could achieve those time cycle using some performance optimization, for instance, customizing thread priority using CPaaS infrastructure and the runtime and real-time flexibility. We could also isolate the virtual CPUs for particular resources for critical virtual IADs. And finally, in Straton, we have 40 to 400 programs that are executed at each cycle in our virtual IoT, but in fact, we could possibly optimize this using some less important programs that can be executed not every cycle. And finally, one word. As you see, we have virtualized the substation functions. The protection IoDs are not virtualized yet, but my colleagues from research and development are on it, and they are also using extensively CPaaS on this, and the first results are quite promising in this way. I now let the microphone to Erwan for CPaaS.
Thank you, Michael. So let's talk a bit more about CPaaS. Now you have a good understanding of the technical requirements that such project as Airspace needs. So first, virtualization, of course, to be able to put all these virtualized IDs. Real-time is also required for protection of virtual IDs that will come later. Low latency network is also a requirement for real-time. Cybersecurity, because it will be a primary attack target once it is in development. And here with that comes minimal services and specific configuration for cybersecurity. At the beginning of the Airspace project, we looked with RTE to see if there was any existing open source projects that do all these things. And the answer was not. So we decided to build our own project without reinventing the wheel. So that's basically CPaaS from the inside. That's all the open source project that we are using. From the beginning, we are using the base is a Linux kernel, of course, real-time Linux kernel to ensure real-time configurations. We are using cluster tools, Ceph, Pacemaker, and CoroSync to, as Michael said, have a cluster of hypervisor and to be able to handle redundancy and failover of physical machines. We are using OpenVSwitch, which is a software-defined network and virtualized network. You can see that as virtual switches, for example, to link many virtual machines together around a cluster. And of course, the big part is the virtualization layer. So the core of it is QEMU, which is the main virtualization tool on Linux. We also use KVM for hardware acceleration to be able to reach performance. And libvirt is an API that we use to configure more easily CPaaS. And it comes with our configuration tool. For that, we use Ansible. There will be very much many things to say about all that, but today I will only talk about how is it configured with Ansible. So first, what is Ansible? Very quick. Ansible comes with two parts. On one part, you have the inventories, which is just a list of machines. You put virtual machines, you put physical machines, Dockers if you need, and everything is in text-based YAML file format, text-based files. All the machines come with some variables that will be used to configure this machine. For example, what IP address is the machine? How do we connect to it? On the other part, you have the playbooks, which is a set of tasks that will configure the machine. You can basically do any Linux command that you want on the configuration side, and it will use all the variables that you have defined in inventories. Why do we use such a project? First, because you can repeat entirely the process on different sites. So you just have to launch one command and all the configuration will come out, reading inventories and playbooks. If you have a lab setup and an on-field setup, you can reproduce exactly the same thing on both sides. You can automate that. You don't have complex command to launch or buttons to click everywhere. Everything will be automated. And you can version that, comment that, modify that pretty easily because it's text files. Let's take an example. Here is the schema of a CPaaS hypervisor with two virtual machines, so a SCADA and a protection VM that are both related to an administration network. The protection is also connected to the sample value network using a special technique called PCI pass-through, and everything should be configured to PTP. So pretty basic setup. But what I want to present here is what is better. Here is the inventories, the Ansible inventories that we are using to configure exactly what you see on the right. You have the three machines, so the hypervisor, the VM SCADA, and the VM protection, and all the variables that I took that I talk about earlier. Sorry. For example, you can see the hypervisor is connected to a PTP interface on ENO1, a network interface or administration interface on ENO2, and the VM protection is connected to the third interface, but using a special technique, so it's not exactly the same thing. But everything is written in the inventory, right there. Other examples, the SCADA is connected to an administration bridge named BR0, and it's defined in the VM SCADA. The protection is also, so on the same bridge, you can see it here, but also uses a second interface using PCI pass-through. So it's basically what is described here. This is a fairly simple example, but you can have Ansible inventories using hundreds, maybe even thousands lines of code to define your entire machines and your entire substation from a CPaaS point of view, so infrastructure point of view. This is one side, so the inventory side that will be handled by the user, for example, RTE. On the other side, you have the tasks that will apply on these machines, and that are the playbooks that are provided by the CPaaS project. I listed some of them. Configure the cluster for redundancy, configure the network, the time synchronization on different machines. So we just provided the interface where the PTP frames are coming, and everything is handled by CPaaS after that. The network topology with OVS, and of course, deploying all the virtual machines that you want. So it can be the Straton virtual ADs or protection algorithm. It can be the Windows VM-based SCADA of RTE. It can be sample value subscription, and many more, of course. Last slide on the test process that we're using on CPaaS. That's another really important topic that we want to highlight. We have a CI running with each piece of code of CPaaS that is tested using 3 methods, let's say. First is unit tests that we do mostly for cybersecurity. We are based on a French standard, which is ANSI 28. So we are compliant with the standard and have 700 unit tests to ensure that we are still compliant with the standard. We also do real-time tests, so to ensure a time response when an event comes. That is using a cyclic test, so it's a standard tool for testing Linux real-time kernel, and we are pretty good. And we are also doing a more advanced latency tests. So only the reception part, we have a sample value sender, and we have a VM that should read these sample values, and we just want to know how many times it costs for the sample value to go inside the virtual machines. And for all these both tests, we have limits that you can see here, and the CI just don't validate if any of the limits are reached. So it means that we have to redo the code and rethink about it. Now I will let Anthony conclude the presentation.
Anthony, can you do in a minute or two? Because we are already on
Yes,
time.
yeah, I will be quick on the conclusion. So a quick conclusion. So I represented the project as a ship. So Airspace is the ship. CPaaS are the boosters because it holds the project. Straton is the core. Of course, you can imagine that in Airspace there is not only Straton. So it's real. It's running today. The first phase is finished since 2025. So I said there are already 2 sites and the third one in commissioning. Phase 2 should be with more complex systems, with wider sites, so it should be in a few years. And to finish, it's a good example of IT and OT convergence, as you can see. Yeah, we are running out of time for the question. No, I think we still have 10 minutes for the questions. There are a lot of links here. We have a booth downstairs on the Copadata booth with Copadata and Straton Automation. So if we don't have time to answer to everything, you can come to see us.
Thank you for the presentation. So questions?
Hello, I'm Camille Blanc from Schneider Electric, and I will have a technical question about Dockers. For now, even if you are developing real-time virtual IDs, they are not yet time-critical virtual IDs. Around the Docker technologies, there is a potential problem of resource sharing, because they are hosted in the same virtual machine, sharing the same resources. I don't know if in the future you expect to be able to support different Docker from different vendors in the same virtual machine or not. And if yes, how do you envisage to ensure the proper resource allocation between the different Dockers?
Thank you for the question. I will just go, or it will be really far away. Yep, maybe there. Just at the time, we do not expect to have Dockers provided by different provider, but who knows? Maybe it will be the case in the future. It's a good question. For now, all the virtual IoTs are developed by us. Also, we see us as an internal provider for RTE, I would say. But I think the answer to your question is there. In fact, using the CPaaS infrastructure, we can isolate the virtual CPUs. And for instance, as I said here, we have 6 IoTs on site. For instance, we have no problem. In fact, we have those 6 virtual IoTs. They are sharing 2 vCPUs, I think, and everything works well. But we are starting to do performance tests because, as I said also, we will have shortly 40 IoTs, 40 Dockers. And in this case, we have problems, of course. So we already performed some tests isolating some certain Dockers on some certain vCPUs. The idea is, for instance, for the circuit, the breaker failure management automaton. This one, we could not afford to be over 10 milliseconds of cycle. It's critical for us, of course. And in this case, this one has its dedicated virtual CPUs. We are also investigating for other algorithms, for instance, or overload management algorithm. For now, it's 100 milliseconds time cycle, sorry. But in fact, it's not really necessary. It could be less. It could be slower, I would say. So we have also this kind of optimization, of course. And finally, for now, the virtual machine hosting our Dockers has, I think, 4 virtual CPUs and 8 gigs of RAMs, which is not so much, in fact, really not so much. And of course, we can afford more. We are using, I think, Advantech hardware, and we can have more vCPUs, more RAM for this particular virtual machine. And for this, we use what Erwan presented. That is, we can easily redeploy the infrastructure. If we want more on our virtual machine, it's not a problem. It's not a problem. if the hardware is okay, of course. But we can easily change our deployment scripts, and then we have a new virtual machine with more vCPUs, more RAM, and of course, isolate new vCPUs for dedicated Dockers.
Thank you. Hello, Julien Tournier, Sclé, France. So I've started using CPaaS, and I have a few questions. The 10 millisecond life cycle you are talking about, under which circumstances is it measured? Which CPU load, IO load, network stress? Is it something that you measured with a cyclic test and just are there any interaction with other virtual machines when you are doing this test? Or can you elaborate on that, please?
Yeah, no problem. In fact, this time cycle is configured in Straton. So we asked Straton to have 10 milliseconds time cycle between each cycle of the PLC. It's a virtual PLC. And basically, if we are over it, then we have a log. That's a simple way, in fact. We have a log saying we are over the time cycle configured. It's maybe 12 milliseconds, 100 milliseconds, I don't know. So it can be, it's quite easy to see. But yeah, how do we test it? That's the good question. In fact, for now, we don't really have performance tests. We are trying, not really. In fact, during the qualification tests, our colleagues have automated scripts that are quite injecting a lot of different measures.
Yeah, stress.
So there is a bit of stress, but not so much. In any case, those tests are performed with other virtual IoTs, other VMs, with the whole infrastructure, with physical IoTs. So it's a real test, I would say. And we are currently working on performance tests to stress our virtual machine. As I mentioned, we will soon have 40 virtual IODs. We are quite sure it will not work with our current infrastructure. We will have to have more resources. And then we are working on scripting these tests, these performance tests, doing some, I don't know really the word in English, but some storm of events, in fact. It should not happen on a real site, but you never know. So
yeah, you have to be ready to handle that.
Exactly. So we will have some storm of events, some maybe not realistic inputs, but we will test it and we will check each time if the time cycle is respected. So if we are not overwhelming this time cycle, we will check also, of course, our IOs and network, the load of our network. Check also our CPU usage, RAM usage. For instance, it's, as I said, in normal situation, but we are trying to do some more elaborated tests on this.
And my other question is, you talk about PCI pass-through, but in this case, you need one physical network card by virtual machines.
Yeah.
Have you investigated SRUV at the moment or not yet?
Yes, of course, and it is compatible with CPaaS, of course, if you have the dedicated network cards. We have found, in fact, that you have slightly better results using SRUV technologies.
Oh.
I think that's mostly because the network cards are more recent and more powerful, but it's basically the same outcomes. And the only problem that you would have dealing with SRIOV would be that in some cases you also need network redundancy using, for example, HSR or PRP. And today we didn't find any network card capable of doing SRIOV and PRP. So you have to choose which one you want.
Okay. Thank you.
Hello, bonjour. Thank you very much for your presentation. My name is Dominique Jorus from Nokia. My question is not so much related to the technical aspect, but you mentioned that also the gateway is a virtualized function in the solution. So technically, it's perfectly possible. We all know that. But how do you deal with this from an organizational point of view, whether you have to implement a demarcation between who is managing the wide area network and the gateway functions that are related to that, and then the protection, automation, and control people that are more on your IED and the protection functions on that virtualized platform. Can you maybe share your ideas and what you think would be the best practice in that case? Whether everything should be on the same platform or whether you would like to have a demarcation and separate some functions in separate servers, perhaps.
Yeah, in fact, we are quite a big team to develop this new generation of packs, of course. And we have also, of course, protection engineers like me and IT guys more dedicated to using CPaaS, for instance. The gateway is quite in the middle, in fact, because it's using the field data, so to say. And of course, we want to configure it and how to say that I think I don't know really how to answer the question, in fact, but the configuration is mostly twofold. A part is performed by protection guys, I would say, and the network side is performed by IT guys. And all of this finally ends in the configuration tool. So in the end, we get one unique configuration of the gateway with inputs from both OT guys and IT guys. And we get one configuration, and the deployment then on this configuration is obviously performed by maintenance guys.